Good morning. Thank you for your interest in fuel cycle technology program. And my name is Stephen Kung. I will present the 4 topic this morning for you. 2 topic under FC-1 and 2 under mission support, MS. So the first one is the MC-1.1. It's nuclear fuel cycle chemistry. The second one is electrochemical separations. So the fuel cycle chemistry most focus on aqueous processing, and the electrochemical separation is the more focused on molten salt chemistry. So the first one, the title is fuel cycle chemistry. We focus on complexation chemistry, actinide chemistry, radiation-induced degradation, and chemistry. So this is a new topic with a very broad scope to cover general fuel cycle chemistry and nuclear chemistry in general. So we believe this is very suitable for our university colleague to participate in. So our goal is to develop fundamental knowledge and understanding of the complexation chemistry of actinide and the competing metal ions. To study this is to help us to enhance separation and recovery efficiencies. So in this year, we specifically focus on one topic is to enable us to develop a novel new approach for advanced reactor use field treatment and recycling. Conventionally, we focus on light water reactor fuels. As we all know, the conventional light water reactor using LEU, that means below 5% enriched uranium 235. After the fuel being used for 2 years, for example, then we still have 1% U-235, maybe 1% plutonium-239 left in the used fuel. But if most of the advanced reactor concept, they use high assay LEU, that means from 5 to 20%. In that case, they may have a lot of valuable material, uranium and plutonium, left under the spent fuel, a used fuel here. So we are focusing on that kind of reprocessing. We hope our university colleagues can help us to provide leadership and advice to us to move forward toward that direction. So something new for this year on this topic, besides I mentioned the focus here, is we also changed the funding limits from 800 to 600 K. In this case, we want to have a less funding so we can support more projects in that sense. Also, I will continue serve as your headquarter program manager. We are in the process of hiring new staff here. Until the new staff is come on board, I will be your contact point at headquarters. And of course, Terry Todd will continue become our laboratory or technical leads. That's about for the first topic. And the second topic I'm going to cover is fuel cycle 1.2, electrochemical separation, aka pyroprocessing. So this is a continued topic from previous years. We feel strongly this is very important to our program. So and then last year we didn't get enough resource to fund this topic. So we issued the call again for this year. So hopefully last year, if you prepare topic proposal under this area, you can refine your proposal. You can continue to support this topic here. Our goal here is to enable separation of, I'm sorry, this one. Our goal for this one is for solubility data generating using experimental methods. Here, solubility data are available from a lot of binary and the ternary systems. But once we introduce the actinide and the fission products, say rare earths or other elements in this system, so we may experience some some knowledge gap here. And secondly, we experience the issue for us is we sometimes see the inconsistency of this data set. Sometimes they may be all correct, but we don't know why it generated different results in this case. So we encourage you to help us to do this area. First of all, you can help us to understand the pedigree of the salt you studied, or the impurity in the salt, why they behave differently. So in that case, we can better understand the solubility of thermochemical data. Another topic we are very interested in this area is to develop the innovative high throughput method to generate this data. So that's another area. So we know to generate this data is very laborious. So if you have better idea how to generate this kind of information, we encourage you to submit proposals here. For the change of this program this year is we limited for 2 years and 400K. So that's the change for this year. Now I'm going to cover the mission support, fuel cycle technologies. In this area, we have 2 topics. Again, I will be your federal POC, point of contact, and technical lead from the lab is Mark Williamson. You will see his information list here. The first topic we covered here is understanding, predicting, and optimizing the physical property, structure, and dynamic of molten salt. We understand the limit of data collecting from our previous program support molten salt activity. In that case, we focus on chloride salt only. But in this case, in this topic, we want to have more model development and simulation under this topic. So they will enhance to complement our data collecting efforts. So we hope you can help us to develop and use first principle molecular dynamic simulation and the computational electronic structure method to extend our limited experimental data set. So in this case, we don't need to do all the experiments. So this model can help us and guide us. So under the 3 topics here, I'm sorry, I forgot to move this one. Under the 3 topics here, apply molecular dynamic simulation to predict molten salt thermochemical and transport properties. The second one is build multiple component model for predicting phase diagram. And the third one is develop advanced model to guide and the experimental effort and to manipulate the molten salt thermal physical properties. So the key word is to guide the experiment and also help us to manipulate the salt composition. Then we can find breakthroughs in this case. The major change for this topic this year is we limit for 2 years and 400K. The last topic I'm going to cover today is MS-FC-2, understanding the structure and speciation of molten salt in the atomic and the molecular scale. So we want to understand how the structure and dynamic of molten salt impact their physical and chemical properties. Basically, we seek specifically using advanced characterization tool and instrumentation method to provide information at the atomic and the molecular scale. So in other words, we want to know the local structure of the salt and then the chemical species of the salt, the relationship of this property, this kind of experimental data related to the property, the molten salt property we measured. So we can, in this case, for example, the electron distribution among the salt, and also the density of the electron once you have this actinide or lanthanide or rare earth introduced into the system, how will they change spectroscopically? So in that case, we can better understand the salt property, why it behaves like that. At the end, we want to, using that kind of knowledge, develop predictive models. That's our ultimate goal. So the change for this topic this year is, again, we limited the funding to 600K. That's about my talk for today. I thank you for your interest in our program. And one of my colleagues, Kimberly Gray, will cover the material, the waste form and off-gas this afternoon. So that's still under our FC-1-1 scope. Thank you.
If any of our online attendees have any questions, if you'll please type your question into the GoToWebinar application, we'll be glad to ask them here in the room with Dr. Stephen Kung. And just so everyone knows, after the webinar, once it gets converted to something we can put on the web, all the webinar presentations and the videos will be stored on the neup.gov website, where you can see them anytime and download them. Okay, looks like we have a first question. What salt chemistries are of interest now?
Chloride salt for the program support. That's the salts. For the mission support, fluoride salt and chloride salt, both salts.
We'll hang on for about 20 more seconds, and if we don't get any more questions, then we'll let Dr. Kung go. Okay, I see a couple more. Okay. For MS-FC-1 and MS-FC-2, are the salts aimed at pyroprocessing or the molten salt reactor?
Both. We see molten salt can used in the pyroprocessing as an electrolyte, but when the molten salt applied to reactor, it can be a coolant or a solvent. So the fundamental knowledge of molten salt chemistry will help both. So we encourage you to be generic in this case.
Do you need corrosion-resistant ceramic materials to contain the molten salt?
That's not under this scope.
In FC-1.1, is the target separation a liquid-liquid separation, or are other systems such as liquid-solid of interest?
Both. We have, this is a new topic. We encourage you to submit innovative ideas. I forgot to mention one thing. You don't necessarily need to use actinide. You can use lanthanide, rare earth elements to study the salt chemistry, the process. Or surrogates for actinide to a certain degree.
Is the continuum level of modeling and simulation of interest to or only atomistic level?
If you can develop some innovative modeling ideas, we welcome that. I'm not saying which one we encourage, which one we don't encourage.
Is there any interest in solid electrolytes for these applications?
Solid electrolyte is not under the scope for this fourth call this time.
While we're waiting for additional questions, the molten salt materials question, there is a scope in RC1 that will be presented later today that will cover that topic.
Yes.
Okay, it looks like that's all we have for these work scopes. So we'll resume again at 11:30 Eastern Time with NEAT 1, the NSUF 1 work scopes, and NE3. Thank you.